In late April 2026, the cost of running advanced artificial intelligence dropped so fast it caught the entire industry off guard. Over a 48-hour window, Chinese startup DeepSeek bypassed press releases entirely, taking to X to announce slashing their flagship API pricing by 75%. The model driving this aggressive price cut was DeepSeek V4 Pro, a newly released system boasting a native 1 million token context window, meaning it can hold and analyze entire codebases or dozens of books in a single prompt. Before that April weekend, Western frontier models like OpenAI's GPT 5.5 and Anthropic's Claude Opus 4.7 were the primary options for this kind of heavy-duty analysis. Running complex million-token tasks through those models required massive, sustained enterprise budgets. By releasing a system that matches those capabilities for pennies on the dollar, a startup operating far outside Silicon Valley has challenged the financial logic that once protected Western market dominance. While GPT 5.5 charges $35 per million tokens and Claude Opus 4.7 costs $30, DeepSeek delivers that volume for $1.30. Crucially, this doesn't mean a drop in reasoning. On the MMLU Pro benchmark, DeepSeek scores 87.5, matching top Western models. And even when the 75% promotional discount expires in May, the base price remains roughly 1/7 the cost of its American competitors. This pricing is a permanent reflection of structural changes in how the model operates. A system delivering near state-of-the-art intelligence at a fraction of a penny per interaction is a significant market shift. To understand how they achieved it, we have to look at the engineering under the hood. The major technical bottleneck of 2026 is memory. When an AI processes a massive 1 million token context window, the computing costs usually spiral because the model has to continuously reevaluate every piece of data it has absorbed. DeepSeek V4 Pro is a massive system built with 1.6 trillion total parameters, the individual connections that allow it to recognize patterns and generate text. Instead of firing the entire network, a mixture of experts architecture selectively activates a pathway of just 49 billion parameters. Paired with a hybrid attention architecture that deeply compresses how it tracks words, this mathematically reduces computing operations by 73%. The model achieves its affordability not through brute force, but through brutal, calculated algorithmic compression. That intense focus on compression makes sense when you look at the physical hardware DeepSeek had to work with. Their pipeline was built without the Nvidia GPUs used by Western competitors. Instead, the model was trained natively on domestic, Chinese-manufactured Huawei Ascend 950 processors. For years, U.S. export controls were designed specifically to block Chinese tech companies from importing top-tier chips, with the intent of starving them of the raw compute power necessary to build frontier AI. Being entirely cut off from a limitless supply of advanced hardware forced DeepSeek into a survive-or-die scenario. To compensate for hardware that was harder to network and less powerful, their engineers had to find algorithmic shortcuts that squeezed frontier performance out of domestic silicon. By legally restricting access to hardware, U.S. sanctions inadvertently created the exact pressure cooker environment that birthed a hyper-efficient, market-undercutting competitor. DeepSeek then took that efficiency and optimized it for distribution, releasing the complete weights of V4 Pro totally open source under a highly permissive MIT license. The 75% API discount running through May 5th acts as a calculated land grab. By dropping the cost so dramatically, they can rapidly stress test their own infrastructure while locking in a massive developer base, and they removed the friction of migrating. For developers currently paying high premiums to OpenAI or Anthropic, switching to the cheaper model requires zero code rewrites. They simply update the base URL and change the model name in their software. DeepSeek is actively weaponizing open-source efficiency to force Western incumbents into a defensive pricing war. The immediate practical consequence of this price crash is that massive autonomous tasks, often called agentic workflows, are now economically viable for the general public. Agentic workflows allow an AI to independently navigate, read, and analyze massive systems, like entire software code bases or massive legal databases. Previously, the token cost of doing this made it prohibitive for many. Now, solo developers and startups can run these massive tasks without draining their bank accounts. It proves that the strategy of simply throwing more expensive hardware at a model to guarantee dominance is no longer the only path forward. The drop in the global AI price floor shows that software-level efficiency competes directly with raw hardware as the defining factor in artificial intelligence development.